Okay, now this is the most important idea. You interchange x and y. Okay, now my expression is x is equal 9 minus y over 5. Okay, and you do something in order to solve for y. For example, multiplication by 5, 5x is equal to 9 minus y. So for y, maybe I move y to the left, positive, and 5x to the right. Okay, and this is the answer. And this is the answer, que by the way, corresponding with the option D, no? Okay. Any question? Easy. Any question? No question? No? You understand very well? Okay, just in case, to verification, like a verification, okay, everything is okay or no, we can put together all. Okay, one way, one fantastic, I like so much, is I put in decimals. Look at that. I put in decimals. Okay, look, I create one script in decimals about our review, no? And the question one, look, the question one, I copy both. I copy the original, I copy the inverted, I copy the identity function, no? And when you plot that, bang! Look, the blue one is the original. The green one is the inverse function, and the identity function I put in dotted. You see clear, super clear, it's perfect symmetric with respect the line y equal x. This is one way to verification this. If you need to verification, no mandatory verification, no? Another way is the composition. Okay, another way is the composition. Okay, let's do it quickly. The composition part. Okay, composition now. Okay, composition is you put inverse function. So if you replace, so look, replace this expression here. Okay, we have 9 minus, no x anymore. But sorry. In the y place, ¿no? Bueno, no, it's okay. Entonces, negative 5x plus 9. Yeah, divided by 5, no? The thing I'm doing is the composition. I put the inverse. This is the inverse. And this is the original. Composition. Do it in this order. F composition, F inverse. To say you apply distributive property, you eliminate the parentheses 9 plus 5x minus 9 divided by 5. Wow, look at that. What happened? The 9 is cancelled. Stay alive. 5x over 5. 5 is cancelled. Division and multiplication. And we get the identity function. Exactly, we expect it always happen. But this is not exactly mandatory in this example. Okay? Good. Let's move on to the second. The function is more interesting. It's y equals cubic root of x minus 8. Okay, now interchange. X is equal cubic root y minus 8. And to say this, when you are doing this action, interchange x and y, actually the new expression is the inverse, but it's expressed in Please, implicit, implicit. Implicit no good, implicit no clear, implicit form. I need explicit. Explicit is when you isolate the y, explicit form. Okay? Entonces en explicit, well, I cubic both sides, cubic. We have x cubic is equal y minus a. So for y, entonces x cubic plus 8 is equal y. And this new y is the inverse function. In this case, corresponding with the option B. I guess so. See, I make a mistake, you correct me, guys. Any question? Easy. You ask me if you have question, no? Do you follow me? Oh no. Okay. Number three is is similar. It's f of x is equal 5x cubic minus 7. Now, okay, I replace immediately f of x for y, you know, it's the same. So they are a perfect correspondence in between f of x and y. No? This is the same thing, but this is using function notation, no? It's very, very comfortable to understand transformation, reflection. However, not necessarily it's equivalent, I replace. Now this is a crucial moment in which you interchange x and y. X is equal 5y cubic minus 7. Now the only thing you should do is isolate the y. I adding 7 divided by 5 and take out cubic root. I do too fast or I do okay? Okay, step by step is x plus 7 is equal 5y cubic divided by 5 both sides. X plus 7 over 5 is equal y cubic, but I need y alone, just take out cubic root both sides. And this is cancelled, stay y, is the inverse function. And this is again is the option B. Any question? No? Wow. Okay. Let's do number 4. Number 4 is a little bit more interesting. F of x is equal x plus 5 over x minus 1. Okay, this is y equal x plus 5 over x minus 1. Now interchange x and y. This is x now. This is y plus 5 over y minus 1. No? Okay, now I might need to manipulate a little bit algebra. No big deal to solve for y. So I propose you cross multiplication. You multiply x times y minus 1 is equal y plus 5. You remove the parentheses property. See, my goal is solve for y. Therefore, I move and y to the same side. In this case, I prefer to the left. And to say in the right hand side we have x plus 5 or 5 plus x is the same. Now I factor out y is x minus 1 equal x plus 5. And finally divided by the factor x minus 1 both sides. Y is equal x plus 5 over x minus 1. And this is, I suppose, the inverse function. Wow, but something is weird in this problem. Okay, the expression for the inverse function is exactly the same of the original. Is possible this idea or impossible? I have no idea. Sometimes happen. Sometimes happen. To verification, everything is okay. O sea, any function que es symmetric with respect the line y equal x when you are doing the inverse function, it's the same because it's perfect symmetric. This is the case. Let me see in Desmos to understand a little bit this problem. Okay. Let me try. Okay. I suppose in that moment you see Desmos. Yes or no? Okay, number 2, number 3, number 4. Okay, no? Okay, okay. So, okay, I share the screen for the Desmos. No, yes. Now, yes. Okay, now, yes. Okay, number 4. Look at that. Number 4 is, okay, I copy 2 times. There's no reason to copy 2 times because the same, no? But okay. Look at the graph. The graph is in black color. You see that graph is completely symmetric. It's a coincidence to the line y equal x. And when you find the inverse function, it's obvious it's the same. And the inverse is the red, okay, by the way, is the same for the black, okay, because it's symmetric with respect to the line y equal x. This is the explanation for this. Was clear? Was confusing? Okay, professor, but it's possible. Of course, it's possible. There are many functions que have this situation. The most typical example of the other function que satisfy this condition is, for example, the reciprocal function. The reciprocal function is y equal 1 over x, no? You know, it look like that. So this function is perfectly symmetric with the line y equal x. Okay, this was the function, the inverse function. Entonces now, suppose que yo interchange x and y, x is equal 1 over y, and when you solve for y, flip it, 1 over x equal y. And we come back at the beginning. Okay, this is normal. No normal. This is no typical. This is weird, but it happens. It's possible. I know. Any question about the inverse function? Okay. Let's move on to the question 5. Question 5 now. In the question 5, day 1, okay, we are doing the graph of that function. Okay, entonces I recognize que es exponential function. I recognize also that the base is 7. And when the base is 7, I know que it's exponential growth. So the exponential is increasing. And the typical point I can plot is the universal point, que es the point 0,1, universal, and another point que is 1,7, because when you only 1 here, 7 to the 1 power, of course, 7. And a -1 is a reciprocal, -1 over 7. Okay, this is the typical point. I know also, so I'm using my best, just in case I check in Desmos. Okay, I plot the famous universal point. Okay, 0,1, 1,7, entonces 2, 3, 4, 5, 6, 7, I suppose. Here, this is the point 1,7, and -1 is 1 over 7, que I have no idea, approximately that. 3 points. We are doing the graph. I also remember always have horizontal asymptote here. always have horizontal asymptote at y equals 0. 3 point, 1, 2, 3, enough to do any graph. Wait, and domain. What about domain and range? Well, it's classical. Domain is already a number. Remember, exponential function is not -0, whatever. Logarithm, no. Exponential, yes. And the range is only positive value, not including 0, because it's asymptotic and the blue curve never cross or touch. The x-axis, therefore, is from 0 to infinity. Entonces ahí select domain. I select, I have no idea. I select the option C, maybe, no? C. Let's see. It's option C. Just in case you want to see more clear, of course we are doing this one. And Desmos, we try quickly. Wait. Okay, I have Desmos. I share the screen now. There you go. Desmos. Okay, sorry. Now Desmos. Do you see right? Okay, it's a question 5, no? Question 5. Question 5 is the classical exponential. Look. Okay, and the typical point are 0,1. Look at that. 1,7 because the base is 7. And negative 1,1 over 7. Okay, put it here like a fraction. Okay, you see it here in decimal. Okay. Super easy. Do the graph of any exponential. Do you see or no? Again, we come back to the whiteboard. Okay. So no problem with do the graph of the exponential. Let's do another graph of the exponential, number 6. And number 6 is a little bit different because this exponential is no exponential growth. It's exponential decay. How do you know? Well, because the base is 2/7, and 2/7 I know is less than 1. Therefore, we plot the classical point, 0,1 again. We plot the 1,2/7, and 2/7 in decimal is, I put in my calculator, 2/7, and 0.28. No, actually this point is 1,0.28 approximately, 25, 3 decimal places. And negative 1 is reciprocal, and reciprocal is 7/2. Okay, 3.5. Okay, no. 7/2 reciprocal. Okay, it's the point, negative 1, 3.5. In this case, it's exact. And so this is approximation. This is approximate, and this is no approximate, this is exact. Okay. But entonces the graph look like that. The classical universal point, 0,1, and 1, and negative 1. And 1 is 0.something, it's supposed to be here. And 3.5, those are 1, 2, 3, 4, and between 3 and 4, approximately here. And the graph look like that. And don't forget the asymptote, the horizontal. So the only difference is, okay, this is decay. exponential decay. O sea, es decreasing, and the reason is because the base is less than 1. Entonces, domain is exactly the same. Domain is all real number. This is classical for any exponential function. No restriction. Domain is all real number. And the range is from 0 to infinity. Only positive value. No include 0. Entonces you select the option C, I guess so. It's not important. The multiple choice is not important because the test is not multiple choice, no? Is you need to show the word in detail, no? Okay. Any question, guy? Super clear or super confusing? Clear. Okay, number 7 is a little bit more interesting because in number 7 we have a transformation. We have transformation. Suppose we have the function f of x equal to x plus 1 minus 4. So actually it's the exponential. However, I can see we have two transformations. We have horizontal shift 1 unit to the left. And we have vertical shift 4 units down. 4 units down. Now, see, it's 4 units down. The horizontal asymptote, que normally is at y equals 0, now would be y equal -4. The horizontal asymptote now is at y equal -4. We are doing here -1, -2, -3, -4. Y equal -4 is our horizontal asymptote. Okay, one more thing. Bueno, okay. Let's evaluate, for example, let's evaluate at x equals 0. Y is equal to 0 plus 1 minus 4. 0 plus 1 is 1, 2 to the 1 power is 2, 2 minus 4 is -2. This is the, by coincidence, in this case, at this point, is the point 0, -2, que es the y-intercept. I plot that. -4, -3, -2 here. There you go. We have the first point, que es the y-intercept. It's the point when our function crosses the y-axis. One more information. Well, suppose at x equal 1. Well, at x equal 1, y is equal to 1 plus 1 minus 4. 1 plus 1 is 2. And 2 to the second power is 4. If 4 minus 4 is 0. It's a coincidence that this point is a point 1,0, no? Que es the X-Intercept. You always evaluate in 0 and 1, que was 0. What about -1? Okay, let's do a -1. Because we will need at least 3 points to make a graph of any curve. Entonces, suppose x equal -1. Well, entonces y equal -1. Wait. It's okay. Okay, now our graph look like that. Look. And this is asymptotically here. Okay, let me see in Desmos to clarify. In this one, we are doing the question 6. Look, no, it's not 6, it's 7. Sorry, it's 7. Oh, okay, I got it. Okay, this is the exponential. We have vertical shift 4 unit down, and the point are 1, 0, 0, -2, and -1, -3. The reason is because I misunderstand something. I come back to the whiteboard. Okay, whiteboard. Okay. So y is equal, suppose 2, -1, plus 1, -4. -1 plus 1 is 0, and 2 to the 0 is 1. And 1 minus 4 is -3. And the point is the point, -1, -3. Okay, here, and -1 is 1, this is -1, is -3, que I suppose que es this point. Okay, this point is the point, -1, -3. That point was 0, -2, and this point was 1, 0. We can plot more, pero I suppose que no necessarily. Don't forget the horizontal axis at y equals -4. Any question, guys? Entonces, wait. I forgot something. I forgot domain and range. Okay, domain. What is the domain? Domain is always all real number, and the exponential always is all real number. But the range, no, because the range is the y value, and the y value go from infinity positive here. This is the range to -4, but don't touch -4 because that's asymptotically. Therefore, the range is parenthesis -4, infinity positive. I suppose, no? It's like option A in our multiple choice. Any question? Are you clear? Confusing? Okay. Guy, this is the moment to ask me any question because you don't understand, no? Everything is clear, no? I don't see everything is wrong or you don't understand. This is the moment, no? Okay? Moving on to the number 8. And number 8, let's see, number 8, we have the function que is f of x is equal -3 to the x. This is reflection, the game. It's the same of the, but you know, the base is 3. The base never is negative, so this negative is completely outside the game. This negative is reflection about or across the x-axis. So this exponential with the base 3 look like that, right? Now the new exponential after the reflection look like that. Okay, this is 3x and this is -3x. So in other words, the y value change the sign. So let's try the typical point. No, the typical point is at x equals 0, que es universal. But it's obvious que the y is equal -3 raised to the 0 power. So, okay, don't confusing because this minus is complete. It's totally different. You see -3 to the 0 power and -3 to the 0 power, no? This is 1, but this is -1 because this negative is completely out of the game. This is -1. And the point is 0, -1, que is that point. Okay, at x equal 1, y is equal -3 3 to the 1 power is negative 3. So the point is 1 comma negative 3. I suppose que 1 here, negative 3 is here. Okay. And x equal negative 1 is y equal minus 3 raised to the negative 1, que es 1/3. Okay, it's negative 1/3. And the famous point is negative 1 comma or negative 1/3. And negative 1/3, I suppose negative 1 here and x value and x axis, negative 1/3 is this point. Okay. Domain again, or real number. But the range, no. The range change. The range is, in that case, I can see that our graph cover only the negative part. Entonces, from negative infinity to 0, no? From negative infinity to 0, no including 0. Because the asymptote, in this case, is located here. Okay, we have no, when you have vertical shift, it's the only possibility that we change the asymptote, because our curve is moving totally or down or up, but including the asymptote. Any horizontal shift that you apply directly in the exponential doesn't affect the asymptote, because the asymptote is horizontal. Entonces, the horizontal asymptote, que es the horizontal line, you perform the horizontal shift, nothing happened in the curve, of course, change, but in the asymptote, no. However, if you apply the vertical shift, yes, of course, it's moving. Entonces, in this case, the option que I suppose que is good is the option B. Do you understand very well this or no? No? Okay, good. Let's move on to number 9. Number 9, let me see, bring a new situation, I suppose. Oh, no, I don't know. You say, okay, no, it's the same. It's the same. It's the same. It's the same. The function is f of x, number 9. Okay, but the basis is less than 1. It's 1/2. X plus 4 minus 3. Okay, I can see that we have a horizontal shift 4 units to the left. We have vertical shift 3 units down because it's negative. Okay, I suppose that our horizontal asymptote is located at y equal negative 3. Okay, let's evaluate at the point x equals 0. Okay, this is classical, guys. 0, 1, and negative 1. This is the typical. This is maybe more a little bit complicated, no? But it's okay. X equals 0 is, the y value is 1/2. 0 plus 4 minus 3. 0 plus 4 is 4. And 1/2 raised to the 4 power is 1/16 minus 3. You put this in the calculator, it's negative 47/16. Que es en decimal negative 2.938. Okay, and this is my famous point. And my first famous point is the point 0, negative 47/16. Now at x equal 1. Y is equal 1/2. 1 plus 4 minus 3. 1 plus 4 is 5. And 1/2 raised to the 5th power is 1/32, no? Minus 3 is negative 95/32. Okay, and decimal is negative 2.96875. So we have the point 1, 1 comma, 1 comma, 1 comma, negative 95 over 32. And fraction. Negative 1. Y is equal 1/2 negative 1 plus 4 minus 3. Okay, I select that value, 0, 1, and negative 1. No mandatory. You select any value. Pero, okay, I follow in one rule, no? Entonces, 1/2 raised to the third power cubic, because 4 minus 1 is 3, minus 3. It's 27. 1 over 27, when you put it together, it's minus 23 over 8, que es en decimal negative 2.875. And the point is negative 1 comma negative 23 over 8. Okay. And also 3 points we have in my hand. We have the horizontal asymptote. And that's it. If you want to find another extra point by curiosity, not exactly we need more, but by curiosity, for example, I propose you find the X-Intercept. Well, no, actually the Y-intercept is this. This is the Y-intercept, because I evaluate 0. Pero suppose que I want to find the X-intercept, que es more complicated. Es cuando f of x is 0. So you take the original equation, que is 1/2 original function, x plus 4 minus 3 equal to 0. In this moment, I have one exponential equation. I move 3 to the other side. Entonces, this equation is impossible solving by the traditional way, because 3 and 1/2 never we can find one common base. So definitely we need to apply logarithmic. What kind? Either standard, of course, natural or common. In this case, I don't know why I'm using natural. So you apply natural both sides. So you apply the property number 7, because the property number 7 allows us to move this exponent to the front as a factor, x plus 4 times ln 1/2 equal ln 3. Okay, now you divide x plus 4 is equal ln of 3 divided by ln of 1/2. Okay, by the way, ln of 3 is positive, but ln 1/2 is negative, because remember, when you find logarithm of the number less than 1 is negative 1, when the base is greater than 1. And actually, the x value is negative 4 plus ln of 3 divided by ln of 1/2. Okay, I put in my calculator, and the answer is approximately negative 5.5849. Entonces, the point we are looking for when we are looking for the X-intercept, no? So this graph passing through the point negative 5.5849, because I enforce it at the beginning, the y0. Okay, let me see everything together in this one, no? Do you understand the thing I am doing or no? No? Okay, let's check it out. Just in case when I solve a complicated problem, I verification in Desmos. Desmos is our. IAM is for what? Jasmine, I don't understand your idea. Activate the microphone and ask me directly. What is the thing? This was curiosity.
Can you hear me?
Say again?
Can you hear me? So
yeah, I hear.
where
Come
it
on.
says x plus 4 equals, that's like a LM3?
No, we can apply distributive property if you want. But the thing I did, I don't know if it's good or not for you. I divided both sides by ln 1/2, no? Entonces I have x plus 4 alone divided by this. This is just a number that I can compute it with the calculator, no? Finally, subtracting 4 and end the story, no? This is your question or no?
Yes, I was.
Okay, super,
My
super.
question was like, what is LM4? But I understand now. Thank you.
Okay. Okay, just in case, Yasmin, let's try to checking everything and response. Okay or no? Oh, yes. Let me see. Boom. I switching to Desmos screen. In Desmos screen. Okay. This is question number 9. Huh? Bang. Look at that. Okay, this is the question number 1. Okay, make it sense. Okay, you have one curve like that. Look, because we are working with exponential decay. How do you know? Because the base is 1/2, less than 1. Therefore, this is exponential decreasing. Now we have the horizontal asymptote at y equal -3. Super. And the complicated point we found was, okay, look. The y-intercept. Y-intercept was -2.938. Okay, there you go. 2 additional 0.1 and -1, and the X-Intercept was we computed using a little bit complicated logarithm equation or exponential equation, but the different base. The answer was -5.585,0. So I am happy, super happy, to get exactly the same result that we expect. Okay, by the way, I need to select what option. I suppose it's option A, no? I forgot to say domain and range. Domain is always a real number from -infinity to +infinity. However, the range is from -3 to +infinity. Make sense or no? Make sense or no? Yes. Okay, let me try to switch into the whiteboard. Bam. Whiteboard. Okay, so the last part is domain. Was a real number. And the range was from -3 to infinity. So I suppose que es the option A and the options que we have in the handout. Study guide. Everything clear? Okay. Okay, no more graph. Good. The number 10 question is super elementary. Is you need to write the equation in exponential form. Okay. El logaritmo base 3 of 243 equal b. And they want can you write in exponential. Remember the formula or the the recipe. The recipe is you ask by yourself. This is equivalent. Equivalent but expressed in another way. In exponential statement, the base is 3. You put big 3. So this is small 3, you write big. The exponent is always the answer of the logarithm, b. And the result of this is 243. This is conversion, logarithmic statement to exponential statement. And this is perfect equivalent in both directions. Okay, it's the same idea, the same computation, but expressed in different way. Logarithmic or exponential. I select the option A, no? In that case. The question 11, I suppose it's different. It's completely opposite. Write the word or phrase que the best completed statement. Okay, blah, blah, blah. El logaritmo base 3 again of the 1 over 243 is equal, this is given, -5. And they want you to express it in exponential. The base is 3 again. The exponent is -5. And the result is 1 over 243. In this case, it's similar. In this case, the answer of this equation is 5, but you don't need to solve it. But we see -5, entonces es reciprocal. It's the same result, pero flip. Make sense? Okay, 12 is similar. 12 is logarithm base 4 of 1 over 64 equal -3. Expressed in exponential statement is the base is 4, the exponent is -3, and the result is 1 over 64. Okay, the option, let me see, option B, no? Okay. And 13 is logarithm base 49 of 7 is equal 1/2. When you convert to exponential, the base is 49, the exponent is 1/2 equals 7. Okay, and the exponent fraction is like a square root 49, no? Okay, of course, it's 7. This system is super perfect. However, they want it that way, is option A. Okay, everyone follow me? Easy, or complicated? Easy, Sean. 14. Let's move on. 14 is write the equation and logarithm 4. Okay, now we are doing backward. Easy, super. A to the third power equal B. But they want to convert like a logarithmic statement. So you put the famous word log. And what is the base? The base is A and the exponential statement. You open the parenthesis always because this is look like a function notation. This is the name of the function, no, log8. And the answer, I know very well the answer is always the exponent. The exponent is the answer. And the rest is missing here, B. This is the option B. 15. 15 is 4 to the -3 equal 1 over 64. I convert to the logarithm statement. Log, the base is 4. I open the parenthesis. The answer here is -3, que es the exponent. You keep in mind que the answer que offer the logarithm is the exponent and the hypothetical exponential. And this is not hypothetical, it's the exponential que given, no? It's 1 over 64. Que es the option D, no? D. All right. Okay, super. 16. 16 is simplify. Oh, okay, let's do it. 16. Logarithm base 9 of 1 over 81. Okay, let's try. I try to find the answer, no? So there are many ways to do that. One way, let's do it in both ways. Let's do it by hand and let's do it by calculator. Using the chain of base formula, no? By hand is, I don't know. I have no idea. I put X. I immediately change to exponential. The base is 9. The exponent is exactly I am looking for. And the answer is 1 over 81. Okay. So this idea can look like complicated. Maybe. Some people know, some people see clear. Some people know it's confusing. It's more clear, so you change to exponential. Sometimes it's backward. Sometimes it's complicated in exponential and you switch into logarithm. But I know that 81 es 9 squared. Entonces es 1 over 9 squared. Y I know that this reciprocal is 9 to the minus 2. Therefore, we have two exponential in that moment. The base is the same, que es 9. Therefore, the conclusion is then x is negative 2. This is the thing by hand. Some people say, no, professor, I don't like this way. It's complicated for me. Okay, I understand. And you apply the famous change of base formula. The change of base formula say logarithm of the any base of the one expression I call x. I copy the formula. Is equal logarithm of another base of the same expression divided by logarithm of the same base of a, que es the original base. So we have two bases. A is the old base, or the original, or the given, and B is a new one base. Suppose que to understand this, or to understand, no, to compute it using the calculator, we need to change to the standard base, que is the only calculator we have available in our. So basically, logarithm base 9 of 1 over 81 is equal. Suppose I make a decision using log, o sea, common, of the same expression. I copy exactly x divided by logarithm of base standard. And this is 9. Ready to put in the calculator. In the calculator, put log 1 over 81, close the parentheses, division, another log of 9, close the parentheses, press enter, negative 2, same answer. Wow. Any question, guys? That was number 11, no? No, 11, no? That was number 16, no? 16. Super, 16. Okay. Good, very good. Any question, no? This is clear for you? So you understand very well conversion, exponential to logarithm, logarithm to exponential. Let's do in the graph, why not? Of the, so this is 17, no? Graph this. Y equal log base 8 of x. Okay. Remember, what is the typical point in the logarithm? It's a little bit different. The typical point is at x equal 1. I know the logarithm of the any base of 1 is 0. So this is the famous point. This is the y value. 1, 0 is the universal point for the any logarithm. So any logarithm graph that you want to do, you include always 1, 0. Another point is 8 is the same base because I know the logarithm of base a of a is 1. And this is the y value. So the point is a, 1. And another point is reciprocal of a. When you compute the logarithm of base a of 1 over a, it's obvious it's negative 1. Because the exponent that you need to raise, so power 1 over a raised to the negative 1 is a, no? Entonces the point 1 over 8, negative 1. Okay, entonces let me try by hand, and after we see in decimals. And by hand, okay, I need to know that any logarithmic graph have a vertical, asymptote at x equals 0. This is very fast. And the point, the super famous point was 1,0 here, 1,0, 1,0. Another was 8. Entonces 2, 3, 4, 5, 6, 7, 8,1. Es important que you understand que the logarithmic function increasing, pero increasing slow, very, very slow. This point is 8,1. And 1 over 8, I suppose, is super hard to see, but you divide by a portion, divided by 2, divided by 2, divided by 2, suppose this is -1. This point is the famous point, 1 over 8, -1. Okay, so our curve look like that. Wow. You know, logarithmic function increasing, but increasing is very, very slow. You compare, for example, comparison. Logarithm is something like that. Linear is something like that. So my comparison, what function increasing faster, linear function or logarithmic function? Logarithm of any base, regardless of the base. It's obvious that the linear increasing faster. And exponential, wow. Suppose 10. The base, because in this comparison, I omit the base here. Entonces, default I suppose que es 10. But in this case, no 10, it's 8. Okay? Okay, but I am confusing, very, very, very confusing. Well, I select the option A, no? Just in case, in Desmos, I want to see. Question 17, no? 17. Question 17. Question 17. Question 17. Okay, I go to Desmos to understand the problem. I switch into Desmos. Okay, now Desmos. Question 17. Okay, 17 is something like that. Wow, look at that in green color. 17, the point I plot was, well, I plot the function with the base 8. I plot the famous point 1,0, universal, 8,1, and 1 over 8, -1, que es 0 point in decimal, 0.125 thousand. Okay, -1. Any question? Any question? Okay. No? Everything is clear. You expect to get good grade in this test? So logarithmic and exponential is easy for you? Yami said yes. Okay, so try to do your homework and try to do the test. I don't know if I plan in pre-test also or no. Remember, pre-test is not mandatory. Pre-test is one help. Because sometimes, not always, I create do anticipation for the test, no? So you feel strong in the pre-test, so you are doing good in the test, but I don't know, because some people omit, some people don't care or have no time to do the pre-test. Okay, I understand. So you know grade, those are not mandatory. Only grade for the test, 100 points, and for the homework, 10 extra points if you complete with more than 80%. 18 question. 18 question is a classical exponential equation. 2 to the 3x, 3y, the variable is y, equals 64. Okay, this is a classical exponential equation that we can solve without logarithm, not necessarily logarithm. Because I know that 64 is 2 to the 6th power. But if you don't know, you put in the calculator, no? 2 times 2 times 2 times 2. But 64 is classical, que is 2 to the 6th power, no? So in this moment, I have two exponential with the same base. Therefore, the conclusion is 3y equals 6. Divided by 3, y2. Do you understand, guys, that this is magic? The thing that we are doing is magic. We have a exponential equation. And doing this transformation, immediately you convert in one elementary kindergarten linear equation. And you solve it in 1 second. Okay? 18 now. Bueno, 19, sorry. 19 es logarithmic equation. El logaritmo que es ln of x plus ln of x minus 7 equal ln 4x minus 18. Okay. Remember the strategy for solving logarithmic equation. You try to condense it. In this case, not necessarily bring everything to the left or to the right. No, you condense in this and this. That you have a logarithm, you apply the property number 5. Okay, the property number 5 says when you have the addition, two logarithms, you can condense in only one. And only one gets the multiplication x times x minus 7. Equal ln 4x minus 18. Now one similar situation happens. You have one equation that contains two logarithms, but the logarithm is the same base. Therefore, I know that this function is one-to-one function. Therefore, the x value is the same. So I just copy the argument inside, should be the same. Okay, I transform this equation to, in this case, quadratic equation. You apply distributive property, x squared minus 7x minus 4x plus 18 equal to 0. So I put it in standard form. X squared minus 11x plus 18 equal to 0. Entonces now you solve this quadratic equation. In this case, I can see it's easier by factorization, no? Because the number is 9 and 2, no? 9 times 2, 18, 9 plus 2, 11, negative both. One solution is 9, another solution is 2. And that's it. No, mandatory in this kind of equation. You have to check it. You checking, and the original equation, see everything is okay or no. Okay, checking for 9. So natural logarithm of 9 plus natural logarithm of 9 minus 7 should be equal natural logarithm of 9, 4 times 9 is 36, minus 18 is 18. Entonces, this is natural logarithm of 9 plus natural logarithm of 2, because 9 minus 7 is 2, no? Now you're condensing this and this together is using one more time the property number 5. Entonces, natural logarithm of the multiplication 9 to is 18 is equal to itself. Super. I verify that 9 is good solution. But 2 no. 2 is wrong. What is the reason it's wrong? When you plug in 2, you have logarithm of 2 plus logarithm of 2 minus 7 is equal logarithm of, so you here you have 2 is 8 minus 18, no? Immediately you see logarithm of 2 is okay, but this is logarithm of negative 5. This is wrong. It's equal logarithm of negative 10. So immediately you see logarithm of negative number, it's totally undefined, and the solution is not good. The only solution is 9, que es the option A. Super good or super bad? Okay. Very good. I like the upper because it's easy to understand. Okay, 20 and 21. 20 and 21. So we have application now. 20 and 29. We have application right now. Okay. 20. Let me explain it like 20. This is a classical example of the compound interest. What is that? Okay, you have one money right now, okay, called P. P is present value. And so in finance, this is a classical problem. And present value is P. And this money you deposit in the bank account. And the bank account guarantee you one interest rate. The R represent interest rate. And you never withdraw the money during the specific time. It's the time and years. Always the same years. Si it's not year, it's a month, you need to convert it to years. And the formula that I want to present now, this time is mixture in years. And now I need to find the future value. So the money, how increasing my money, future value. And the formula is clear. Future value is equal present value, multiplication, 1 plus R over M raised to the n thing. Entonces I forgot to define M. M is compounding. And compounding depending your bank account. No? We have several bank accounts. Suppose case annually. Annual compounding is 1. Semi-annually. Annually. And it's 2. Because what is the reason? What is the interpretation of this? The interpretation is that means okay, my money, okay, increasing 2 times in 1 year. So this interval is 1 year. 0, 1. 6 months, 6 months. And my money increasing like that. Bang, bang. And 2 periods. And 2, this is like stairs. The money increasing like a stair, like that. But this stair contains 2 steps because it's semi-annually. We have another possibility. We have quarterly. Quarterly is for daily. 365. Monthly is 12. Is 12. And so on. Weekly, que es 52. O sea, ese is the amount of month that we have in 1 year. Because anytime you suppose that the time is measured in years. And this is the most important formula. Compound interest formula. And this is you can see the power of the compound interest. The money increases too fast. Increasing, well, depending the interest rate, of course. This will look like similar to exponential. But what is the difference between exponential? The exponential is continuous function, no stairs. Exponential is like that, smooth exponential. E to the x, or 10 to the x, or the base, any base to the, and this is no exponential, no smooth, it's discrete. The money increasing like stairs. Okay. Because in our problem 20, the problem talking about, okay, we have $1,000. P present value is 1,000. It's the money that you have now. You deposit in one bank account, the interest rate is 6%. And this is annually. This is annually. I know that N is 1. The compounding is 1 annually. Okay. And the period is 8 years. At the time is 8 years. Okay, those I using my famous formula. Future value is equal to 1,000. Parenthesis, be careful, because interest rate normally, frequently, is expressed in percentage. However, in the formula, never. You put 6, you put in decimal. You convert to decimal, 0.06 divided by 100, right? So 1 plus 0.06 divided by m, pero in our example 1, raised to the multiplication nt, que is the amount of period and what our money increasing, the amount of the step of the our stairs. Entonces es A because it's A times 1 because the compounding is 1. And you put in a calculator and that's it. And the answer is $1,418.52. So you truncate or you round the money to the 2 decimal place because it's the same. It's a currency. So you truncate or round to the near 200. Okay, que corresponde with the option D. Corresponde with the option D. This is clear or is confusing? It's a formula. It's a formula. It's like a one application. Actually, this is exponential. But another kind of the exponential in which the function no is continuous, is discrete, discontinuous. We have another problem, 21. 21 and 21, let me copy the information. Again, we have present value, 1,000. Invested interest rate is 10%. Compound semi-annually, so en esto. After 8 years. Okay. Si es semi-annually, y es a year, okay, entonces the money increasing like that, look. Okay, this is 0, 1 year, 2 year, and so on, no? 3 year, but the money increasing like that. Bam, bam. So now we have, in 1 year, we have 2 steps. Bam, bam. And the step, by the way, is not the same high. Maybe it's increasing, exponential, increasing more, increasing more. Entonces, actually, we have 16 period, 16. Where come from 16? 8 times 2. So my stairs contain 16 steps. But I don't care. I don't care. I copy the formula. Future value is equal present value. 1 plus r divided by n raised to the nt. Future value is equal 1,000. 1 plus, don't forget to convert to decimal, 0.1. 0.1 divided by 2, because compounding is 2. And multiplication nt is 16. Oh, do look at that. This is exponent is 16. 16 step. Put in a calculator. I would like you put in a calculator. Please try to practice this computation in your own calculator right now. And let me know what the answer. We practice with the calculator now and the application, on the word problem application. You put in the calculator 1,000. Very, 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 very well. Very, very, very well. Jasmine, say que es $2,182.87. Que corresponde with the option D. Any question? Please. Are you clear? For sure, in the test we have problem, application problem. And one typical problem is this: finance. Find the future value, find the present value, depending, no? Okay, in this case, the information is given, and the unknown is future value. But not necessarily always is the only unknown. And this is 21. 21. Okay, let's move on to the 22. 22 is a word problem. Okay, let me erase everything. Okay, 22. 22 is no money anymore. Now it's another kind of problem. This is like maybe biology problem or physics problem or chemistry problem that somehow involve exponential or logarithmic function, no? In this case, it's about the rabbit. Okay, 22. We have 120 rabbit. So basically, it's the population. Population normally of the microorganism, like a virus or bacteria, and a small animal, like a rabbit, increasing approximately, exponential, using the exponential behavior. So the formula is population at any time is P null. P null represents the initial amount of rabbit that we have in a problem, or bacteria, or virus, whatever. This is initial what? Initial amount of population. Time exponential KT. K represent, for example, in finance, K is no K, it's R, it's interest rate, but in this case, no. In this case, K represent the rate of change. I'm saying what increasing, what rate increasing, because actually we have a family of the exponential, no? Rah. And one exponential, suppose K is 1, K is 2, K is 3. Si K increasing, it's obvious that the exponential increasing faster. This is time and this is population. But K, well, it's not given in the problem. I need to find, I suppose, no? Okay. So, well, let me try to understand. We have at the beginning, initial population, 120 rabbit. Black nose rabbit. In the forest, natural forest, in 1990. Okay, I suppose we have to date. I suppose that this is the initial, entonces t equals 0. I suppose that at the beginning 0 is 1990. In 1993, the problem say okay, we have 240. Wow, the population increasing too fast and the rabbit. This is t equal 3 years, no? 3 years. Okay, let me try to understand. Understand what's the goal of the problem. This axis represents time in years. This axis represents population of the rabbit. At t equals 0, here. Okay, by the way, physically it's 1990. We have 120 rabbit. At t equals 1, 2, and 3 years. Okay, 1993. We have 240. So the population duplicate, increasing 100%. Like that. And what's the goal? Is the rabbit population following the exponential law? How many rabbits? We have 8 years. Wow. 4, 5, 6, 7, and 8 years. At t equal 8 years. Okay, 9. How many rabbits we have in the population? I have no idea. Do you understand the idea? Yes. Okay. Let me set out the equation we go over. Okay, the population at any time is equal 120 because P null, que es the initial amount, is 120. Exponential KT. This is the condition I want to call condition 0. Condition 0, because the at t equals 0. But we have another condition, condition 1. Well, condition 1 is at t equals 3, but in this case, t equals 3, but another problem is another time. Okay, the condition 1 is using to find the k value, because I know very well the time. So the population at this time is 240. I know that 240. So 240. Remember, this is population at any time. Is equal 120 e to the k, I don't know who is k, multiplication by 3, because at t 3 years, t equal 3 years. Okay, so the only unknown that we have in this problem is k. So this condition 1 is given for finding the k value, que is the rate of change of the exponential. So how the family of the exponential increasing. Look, increasing faster, increases slow. Okay, to say in this moment I have in my hand one exponential equation. Okay, let me try. Divided by 120 both sides. Es obvio que es 2, because duplicate the population. E to the 3k. I want to put a number in the front. Now, to solve for k, you apply natural logarithm. So you apply any logarithm, but in this case, for me, it's easier. Using natural because the base is e. Is equal 3k. Therefore, because you know the logarithm of the e to the 3k is equal to 3k. Why? Because you apply the property number 3, and the property number 3 says you apply logarithm and exponential on the same base undoes each other. I don't want to cancel out like that. It's not good. But this is the intention. Okay, finally, to say natural logarithm of 2 over 3 is k. I finish no. I need to find condition 2, because there's last condition in which you have the time, but you have not the amount of rabbit that you have in the population in these years. I need to find this guy, question mark. Okay, so we come back to the equation. So we're using this equation 2 times. The first time was to find the k value, get this. And the second time is to find the condition 2, no? Using the condition 2, population at 8 years, I have no idea. Is equal 120 again, exponential, but I know the k is natural logarithm of 2 divided by 3, multiplication by 8, get the time. Okay, now I put in my calculator, please. Help me put in practice. Part of the game is that you practice with me now using your own calculator. You put in the calculator 120 multiplication times, I suppose you put it here, period, so I get multiplication, and exponential. The exponential, by the way, in any calculator is in the same key of the natural logarithm. So you have 2 keys in the calculator. So normally in any calculator we have 2 keys. One key gets log and one key gets lm, and the same key in different color. I have 3 calculators. One calculator is blue, and another calculator is yellow. Another calculator I have this is yellow also. We have the okay, super, is the answer, yeah. Jasmine, you have Jasmine say que the answer is 761.95, something like that, Jasmine, no? So, I am explaining que in the same key, but you apply the key que es the second key, no? The second, you select no logarithm, sino the corresponding exponential. Of course, the have no sense logical que we have a fraction decimal of rabbit, entonces you trunc it or round up to 762 round. Es the final answer que corresponde with the option A. Clear or confusing? Clear. Okay, this is a typical problem of the biology, in this case, of the exponential growth. Exponential growth. Okay, let's do one more. 22, 23. 23 is similar. Everyone follow me, guys? Are you boring? Are you tired? Sorry. Let me check it. Lustin, Frank, Jennifer, follow. Okay. Sean, Betancourt, Karin, Bolívar, Puga, Yailin, Yancy, Maria. Yasmin always follow me. I know. I feel that. Queen, are you quiet? And Banks. Amazing. Okay, one more of the exponential growth. Similar, it's a typical problem. Population increasing faster. Okay, suppose 23, no? 23 talking about the population of the particular country. It's a human being. Was 29 million and 19. Okay, 29 million at 1985 in one particular country, not necessarily our country. And the population 40 million at 1990. This is condition 0, I suppose, because you suppose t equals 0 at the beginning, is 85, and this is condition 1, okay, by the way, is at t equals 5, no years. I suppose it's given to find the k value of the exponential. We're using to find the k. K, remember, is the rate of change of the exponential, because actually we have a family of the exponential. Suppose that you have initial point. Good, this is time now. But we have a family, no? So we need to make a decision. Okay, in the family, you select specifically the exponential passing through the condition 0 and passing through the condition 1. Okay, you satisfy both conditions. So yeah, it's perfect defined, the exponential. They want to know, just say more, take the amount of population, in this case called capital A, is equal to 29, because it's P0. This is P0. 29 is P0. Exponential, KT. I need to find K. To find K, we're using the condition 1, que es 40. 40 is equal to 29 exponential KT, pero T is 5 years. 40 divided by 29 is equal to exponential 5 times K. Lo apply natural logarithm, que is the most convenient logarithm. The reason is clear, because you're using the property number 3. Let me recall property number 3. Property number 3 says logarithm base A of the A to the X is equal to X. It's like on dos, this A and this A. Specifically, in our example, is no any base, it's natural of the E to the X, it's obvious it's X. And now we have logarithm of 40 divided by 29 equal, this on those each other, 1 divided by K. Therefore, natural logarithm of 40 over 29 divided by K, divided by 5, sorry, is K. And it's the K value. Wait a second. Exactly, they want that. The question say using the fact of the 5 year, no. The population, find the K of 3 decimal places. So they want to find all the population of the, no. I find the K value. They put in the calculator this, you put in the calculator natural logarithm of 40 divided by 29 inside the parentheses divided by 5. Let's do it. Come on. Participation, not only Yasmin. Another participation. Come on, guy. I want to see your work. Lustin, que always are doing well. Frank. Torresillas. Jennifer. Okay. Sean, que always participate, but today not too much. Betancourt. Karen. Bolívar. Okay. Put in your calculator. What is the answer? What is the answer? The answer is positive or negative? Without calculator, the answer is positive or negative? When you divide 4, it's positive, it's 0.6, okay. It's 0.064. O sea, they want, let me see, it's the option A. Positive. The answer is positive. Banks, amazing. Because 40 divided by 29 is a number greater than 1. And logarithm of the number greater than 1 is positive. And see, the answer is negative. We are in front of the exponential decay. Okay, let's see now in another problem. But no, this is exponential growth because the population increasing, you know, increasing from 29 to 40. Yeah, increasing forever. Make sense? Make sense or no? Okay. Let's move to 24. The 24 is a little bit different. 24 is no biology problem, it's physics problem. Physics problem is about the radioactive isotope. So we have some substance. In that case, silicon, but maybe it's plutonium. Okay, this substance break it down naturally. Okay, because it's radioactive substance. Entonces, the amount of substance, o sea, what's the idea? The amount of substance at the beginning, o sea, is amount of substance to any time. Amount of substance to any time is equal A null, que is amount of substance at the beginning. So at the beginning we have, I don't know, 100%. Sometimes it's a present percent, or no, we have at the beginning we have 10 grams of substance, but during the time the amount of substance decreasing. And the mathematical law that describes this phenomenon is exponential. But this is exponential decay because it's decreasing. E to the kt. Okay? K again is a rate of change, the famous rate of change. What is K in the decay problem? Es obvio que K is negative. So bueno, at the beginning you don't know. You put in the formula like that. But when you compute the K, you expect that the value of the K is negative because it's decreasing. So this exponential decay, the typical shape of the exponential decay look like that. At the beginning, at t equals 0, we have one amount of substance, suppose in percentage, 100%, and decreasing until approach, but never touch 0. Exponential decay, and any exponential, you know, have one horizontal axis here, and the axis amount, this is the axis A, and the formula is A equals 0. But very, very important idea. In the physics problem of the radioactive isotope, we have one parameter important, is called half-life, half-life, half-life. What means half-life? Well, it's a time. It's a time in which the amount of substance decreasing half. So now suppose 50%. And this is half-life time. Half-life time. Que depende de substance es measured. Suppose que es very, very active substance. Entonces disintegrate too fast. Like plutonium. Plutonium increasing too fast. And the half-life of the plutonium is 9 hours. So 9 hours, the half of plutonium disappears, convert in another substance. However, silicon, no? Silicon is not too active chemical element, and disintegrate in 710 years is the half-life. That half-life give me information about how fast disintegration the radioactive isotope. Okay, let's move on to 24. 24 talking about silicon, the half-life of the silicon. Silicon 32. This is the name of the chemical element. Silicon 32. The half-life is equal 710 years. Wow, too slow. If we have at the beginning a null is the initial amount of substance is 10 grams. It's present now. It's present now at t equals 0. At t equals 0. So my equation so far is amount of substance to any time is equal to 10 grams. A null is 10 grams in our specific problem. Exponential k t. And k represent the rate of change, no? The rate of change. Okay, I know que we are in front of the one decay problem, therefore we expect que the rate of change is negative. Because the interpretation of the sign que es negative, that means it's decreasing, go down, decrease. Okay, but I don't care. Okay, now I know que the half of line, o sea, the half line, o sea, okay, what's my goal? My goal is find the k value, I know que the half, okay, let me try to understand. This is my graphic. I don't know, the graph is the geometric interpretation of the problem. We have at the beginning, at t equals 0, we have 10 grams. And it's decreasing too slow, I know, because the half-life is 710 years. But I know for sure that 5 grams occur here in 710 years. This is the interpretation of half-life. Yeah, I want to know how much will be present in 100 years. Okay, 100 years, I suppose that here I have this information of the time. Yeah, I need to know how many grams. This is the thing I try to find is this question mark. Do you understand very well this idea? In my opinion, this is the most complicated part. I understand exactly what we are looking for. Well, for sure, we need to find, well, this is condition 0. Condition 0, this is the same organization. This is condition 1, where the half-life can give me information to find the k. You find the k here. And this is condition 2, okay, the last condition. I need to find, not the time, I need to find the amount of substance. Okay, so I know in the condition 1, the amount of substance is 5, because it's a half-life. 5, where come from 5? It's 10 divided by 2, no? Okay, and you don't know k, but you know the half-life is 17. So for k, 5 over 10 is 1/2. And it's obvious que es 1/2 because the half-life is equal to exponential 17k. You apply logarithm both sides. And you know I don't need to repeat again. Because you apply natural logarithm here, disappear the exponential, no? Because it's the same. Therefore, natural logarithm of half divided by 17. Okay. This is the answer, no? It's not the answer. This is the one partial answer. I need to find the final answer. Es obvio when you put it in the calculator. Okay, I know one fact. Look, I know. They're not necessary. You put in the calculator, and you compute this in the calculator. But no. Let's do it in different way. Look, I know that logarithm of 1/2 is equal negative logarithm of 2. Wow, why? Well, okay. Well, I take advantage of the property number 6. Okay, when you have division, it's logarithm of 1 minus logarithm of 2, no? But logarithm of 1 is 0. So logarithm of 2 is the answer. So you can write, this is not necessary, but well, okay. I like this way. Negative logarithm of 2 divided by 17. And logarithm of 2 is positive, but I know it's negative now. The answer is exactly what we expect because we are working in one decay exponential problem and the rate of change is negative. Okay, you want to find what's going on amount of substance in 100 years. Why don't you evaluate plugging in the original function in this one? The original function is 10 multiplication exponential k is minus natural logarithm of 2 divided by 17 multiplication by 100 get t. Boom! Put in the calculator and compute. I suppose, see, this is 5 and this is 10. The logical value is in between 5 and 10. I suppose it's very, very close to 10. Come on, guys, help me. Put in the calculator. This is a little bit complicated because we need to open the parentheses. So you put in the calculator like that, no? 10 multiplication exponential parentheses negative. Be careful with the negative because our calculator has two negative value and subtraction. So some students make a mistake to press the key subtraction. Wrong. Natural logarithm of 2 divided by 17 multiplication by 100. Close the parentheses. I suppose it's the organization in our calculator, no? Let me see. Let me try my own calculator. This is 10 times exponential second, the same key of the logarithm. Inside we have minus natural logarithm of 2. Close the parenthesis. Division 710 multiplication by 100 and close parenthesis. Press enter. I got the answer. Somebody get the answer? Exactly. Very well. The answer is 9 point something, 9.0698. No, 809. Now it's 9.0698 7277242. I copy exactly the same I have in my display. However, they want you round. You round to the near two decimal place. It's obvious it's 9.07 because the next digit after you want to round is greater than 5 or equal 5. You increasing one more. And the option C. Any question? Well, I suppose que we stop. Okay? We continue. This Thursday with a review package. My plan is, I don't know if I can or no, my plan is finish, no, the review next time. I will send the reading test, so the test on paper. So we have the due date for this is, let me copy one piece of paper. Let me try to find in my smartphone and the calendar. So the calendar to do this, the due date is today is 16, no? Plus 7, 23rd. So March 23rd, I collect the test. I will send this Thursday. Yeah, I collect next Tuesday, is March 23rd, no? And it's due. I want to check and see I is set out correct or no. And Alex is 23rd. And the due date for the test online also and homework. Okay? Clear or confusing? Are you clear or totally confusing? Okay. So I love you. Bye bye. Bye bye. Thank you for everyone.